Welcome to a video on finding a linear equation that represents a real-world situation. This linear equation is sometimes referred to as a linear formula or a linear model. So a book collector had accumulated many books over a number of years, so that by the year 2020 she had a collection of about 3,500 books. She wants to continue to increase her collection by about 150 books per year over the next several years. Now this is a linear model, linear situation, because she's going to increase the collection by a consistent number of books each year. So the same number will be added year after year after year. And so this consistent increase, or it could be a decrease in some circumstances, a consistent increase of an amount each year rather than a percent, makes this a linear situation. So this 150 books per year is the rate or the slope of our linear equation. So we have in a linear model, we have been using y equals mx plus b. So y equals mx plus b. We could use as easily function notation would be p of n. We could use, don't have to use x, use n is equal to, sometimes we say d for a common difference, and then n would be the variable instead of x, plus, and then p sub 0 or p of 0 would be the initial value. So this is linear function notation, with this p, with this parentheses around the n and around the o. But in any case, b is the starting value, so our b value would be 3,500. That's the amount of books that she has in 2020. M, the slope, or d, the common difference, these are represent the same thing. M in this case is 150. It's a positive. Now that's books per year. And then our variable, in this case we could use either x for the number of years or n for the number of years, but that would be the number of years since 2020, since the 3,500 represents the number of books in that year. So our n or x would be the number of years since 2020. So the formula could be y, or I'm just going to use p of n, this is the function notation, is equal to 150 times n plus 3,500. Now taking a look at the next section, it says use the equation or formula from part A to find how many books will she have. Using the equation in part A, how many books will she have in the year 2030? Well, now remember, this unknown, this n is the number of years. Remember, 150 stands for the number of books per year. If that's books per year, you need to multiply that by the number of years. And so in 2030, that's 10 years. If we subtract our 2020 from that, that's going to be 10 years difference. So that's going to be our n, or x if you wanted to use an x in that case. So that means p of 10, that means the population, or the number of books after 10 years is going to be 150 times 10, obviously, right? You have 10 books, 10 years, and you get 150 books a year. So that's going to be 10 times 150, which is, that's 1,500 plus the 3,500, and that's going to be equal to 5,000. So she'll have 5,000 books in 10 more years, or in 2030. Now, according to Formula 1, will her collection double from 3,500 to 7,000? So in this case, 7,000 is the number of books. So part B, it said it was in 2030. That's the number of years, 10 years since 2020. But now you have the number of books, and that's what this represents. This represents the number of books in 10 years. So we want to know when the number of books, the p value or the y value, will be equal to 7,000. So that's going to be, using 7,000 for the number of books, and that should be equal to the number of books plus however many we add, however many years she's going to add those. So we're going to subtract the 3,500 from both sides, and that 75. Of course, if you're doubling it, it should be what you started with, 3,500 more books. And how many years will that take? Well, we divide both sides by 150. And when you do that division, that doesn't come out to be a nice pretty number. That means n is approximately 23, and it has a 0.3 repeating on it. So how do we best answer that question? Well, remember, these are all just kind of estimates. Says about 3,500 books. She wants to increase her collection by about 150 books per year over the next several years. Well, this is 23 1/3 more years. So I would say something like 23 to 24 years from now, or from 2020, I should say. That would be about the year 20. If you add 23 or 24 to that, that's about the year 2043 to 2044. And we don't know when that will really be. Because, to collect 150 a year every year, well, that might change over a 20-year period. So I hope this video was helpful and